returning to the Bassman 100. Just got done drilling these holes. New triode, dual triode tubes, no wall 910. A new trimmer pot in a weird spot, but there's a power transformer on the other side. And you know, a bummer, yeah, I did drill some holes, but you know, this is a 1976 Bassman 100. It's not, I don't think it's highly sought after, but it does look, it's cool. It has a nice cabinet, and it's 100 watt. It has 4 6L6s, and you can run it with just 2 6L6s, and it makes the output impedance match up with 8 ohms, which is a little more convenient than 4 ohms for me. So I'm gonna finish up this bias circuit. So the goal here is to add a Marshall style channel and the 5F6A original 59 channel, kind of to have hopefully the best of both worlds. And conceivably I would put a foot switch in here to switch channels, you know, and a couple of niceties, but I sort of want to keep the hand wired vibe and not put any, like, you know, daughter boards or anything in here with, you know, digital parts. You know, just try to keep it sort of original looking. I did already, just to listen to this amp, I took the master volume out. Before there was a piece of coax that ran all the way over this master volume, and then it came back to this point with another piece of coax. But you know, this is like a pre-phase inverter master volume setup, and you know, I didn't think it really did anything. I took it out completely, and I liked the sound better. But then I just rigged something up temporarily where this is a post master volume, Robinette style master volume, which seems to work, you know, fine as far as I can tell. I think it makes more sense. Tubes, like I want to put a couple 1.2 AX7s in this Bassman 100. I need to drill a 3/4 inch hole, and there it is, the step drill size. Can't see because the camera's in the way, but I need to drill down that far, and I'm going to try out the step drill at around 700 RPM. Hopefully that's not, I think I'll use a little bit of lubricant as well, because okay, I think there's enough clearance. I drilled a couple pilot holes right here, 1/8 inch, and now I'm going to drill the 3/4 inch holes with this step drill. Looking pretty good. Let's get just a little bit of 3-in-1 on here, just to have some stuff to make smoke. Theoretically, that's 3/4 inch. See how bad I biffed it. .749, that's pretty close to 0.75. Okay, the other one. Jeez. Last thing I want in the electronics is metal filings. Okay. Unfortunately, I have these huge counterweights transformers that, as long as you get them over the support they really help with cantilever. Yeah, I still see it. Didn't go over. It looks the same as the other one now. .75. I'm sure that's 0.75. Just bad calipering. Okay, so this Bassman 100 can have up to 4 more triodes to play with to build custom circuitry. It's a 70s silver face Bassman 100, so it's not really as valuable as some of them. So I figured this is a good test bed. Besides, it's a Bassman 100. I'm not really sure. These are real collectors. And I am going to populate all 100 watts for all possible combinations. Okay, I'd like to put tapped sheet metal machine screws into these sockets to hold them down. I think these are number 6s that are in the other ones, and they are self-tapping types. And back to the drill press. So I do have little punch holes. What I'm going to try to do is use a 3/32 inch drill bit, and then I'm going to try to tap these for 440. I think it'll be a little nicer than trying to jam sheet metal screws through this 16 gauge or whatever it is. Steel of this 70s Fender chassis. That was probably painful. Let's see if I can tap them. Well, I'll record this, but I'm not sure it's going to be successful, so I'd never make myself look bad in a video, so I'd cut it out if I screw this up. But the problem is these taps have these T-handles, but there's no room for a T-handle in here, so I'm just going to use the weight of this. Oh, I think I want... No, actually, I want to leave it on drill bit. Okay, so wish me luck. That looks pretty well. Tap for 440, so I should be able to put a 440 machine screw in there. And I'm set. So there it is. So it's going to look on the top. Let me see if I have 4 that look alike. Ooh, these look nice. These sort of. Yeah, I'm going to go with these less, I don't know, plain looking. So. Yeah, I think I tapped it correctly. So there it is, man. This thing just looks like it's done practically. Okay, there it is, as much as you can see with this camera. There's the once again, they have this huge empty space here. There's the original 212X to 7025 locations. So there was a very simple, traditional Fender circuits in the preamp of this Bassman 100. Then there's the phase inverter. So what I'll have is a completely new section for whatever circuit goes in there. Probably somewhat of a versatile, clean, high gain kind of circuit. Clean and high gain. Who knows? Maybe some switches and stuff. See these coaxes from this normal channel here. The normal channel has like these long runs over to this side where the circuitry is. So you see there's a couple coaxes there going all the way over this section. So this will be a lot nicer when I just wire it into circuitry here. Then these will be the knobs for that circuitry, and that will be a lot more practical, I think, noise wise, although the coax certainly doesn't hurt. So there's the tap 440s. They just turned out great. And I checked the rating of the transformer, or at least an equivalent transformer, and it had 6 amps, I think, for the filament. So we should be able to get by with powering these up to two additional tubes. Initially, I may only need 1 tube. So depends on what circuits go in here, whether we power both tubes. One thing I forgot to mention during the drilling, I had drilled an additional hole for, here it is, for another trimmer potentiometer, and I kind of drilled it. I wanted to drill it, put it right, kind of straight across from this existing balance pot, but there's a transformer in the way right on the other side of the big output transformer, so I offset it over here. It doesn't look very good, but really I just want to make sure that the overall level bias adjustment is accessible from outside the box. I've seen videos of people putting little trimmers right here on this balance pot. You put a trimmer inserts with this resistor to ground, and that moves the overall level up and down. But you can't get to this trimmer unless you take the chassis out. So here, at least when I throw a trimmer down in here, it will be accessible from without removing the chassis. Okay, just a little detail about this schematic. This is the mod to the balance circuit. This is the Bassman 100 schematic, and this balance potentiometer right here is what adjusts the relative bias between the push and pull pair of the 6L6 output tubes. So this 15K resistor right here is the resistor we want to make adjustable. So that way it'll raise and lower the reference to this balance pot. Okay, in the spirit of looking at stuff for the first time while the video is rolling, I'm curious about this existing balanced pot for the bias balance between the output push-pull pair. Push-pull pair. So I'd like to know if there's a lock. There's no washer on this side, just a nut. So I'm assuming there's a lock washer on the other side. I guess I'm just going to take this thing off and pull it out on the other side and take a look at the just pulled this out from the other side. There's a bunch of parts, but yes, lo and behold, there's this internal star washer, and that's one of these nice ones that really digs into the sheet metal for its ground, because you can see stuff soldered to the shell, and the shell needs to be grounded to the chassis, which is, you know, potentially a weak grounding point because of this mechanical no solder between the two. So the new trimmer, which is going to go next door in this hole, which you can't see. See if we can even move this in a little further. Here's the hole. There's the internal washer for that. There's the star washer. So here's the new level control that's going to go right next door. And I'll put an internal washer on this one as well. This resistor here will be changed. The right type of range control for bias. Here's the original 1976, what I bought new off Amplified Parts or Tubes and More. Pretty similar. So anyway, that's the nod to I'm modifying the shit out of this thing, so there's really no point in trying to maintain any kind of unmodded kind of. We'll just not worry about that. But I can tell this is going to be perfect. It's almost like this thing was designed for it. I may do the ground on this side and actually make a really nice ground. Or at least a soldered to chassis ground, instead of this conducting through sheet metal parts that is being used right now. Seems like this is just the bias circuit, but it seems like the bias should be as clean as possible. Okay, I set up a fan here to prevent fumes from being breathed during desoldering. These two center pins together, then this 15K that goes to that one or that one, and it probably won't be a 15K, it'll probably be something a little smaller than 15K, but I'll start at the 15K because I have to desolder it from this shell here, and I actually have a potentially better ground on this one now, and so I may ground it to this shell here. I found a use for this 15K, and I'm going to use part of this lead to connect the center taps of these two potentiometers together. I don't understand why those aren't crimped better, but it's a total loop there. And then there. I think it looks pretty good. Alright, so I have this meter on DC voltage hooked across the ground to plate voltage of that 6L6. Here's the Ruby 6L6s. And I have to say, man, those things are crammed together in that PV. And I could barely push the bear trap tube holders apart. I couldn't get my fingers in there, but so that thing was really in there. But they're rubies. I don't know anything about rubies, but I hope they're good. And we're off at this point. I'm just gonna plug it in and cross my fingers that nothing bad happens. So I'm gonna power this guy up. Light should come on. It did. And I'm gonna put on current. Can we see the current measurement? Okay, I have all 4 tubes available here, and I have this plate voltage, and I have the website open to calculate the correct bias current. Okay, so hopefully I didn't leave any iron filings anywhere in a bad place in this circuit. Okay, boom, we have 20 milliamps, I see, and 437 volts. I hope that's visible there. Kind of hard to tell. I can't see my screen. Okay, so 20 milliamps seems low. 437. I'm gonna run this number. 6L6 GCs for 70% bias point should be like 48. Let's try out the new potentiometer. Okay, that was at the low end of the scale, so I'm turning this down and the number's going up, so I guess that's what it is. So it should be, and I can't reach where I want to be. I get to 35, and it's roughly the same voltage. I had 436 before, now it's dropped to 428 since I cranked it up, but it's still nowhere near the 70% point. So I have to make a decision now if I want to swap sides where that 15K resistor connects, and I think I do. I think I want to move it completely over to the other side of that level pot. So when I turn the potentiometer clockwise, oh wait, it's from the top. I turn it clockwise up here, it's counterclockwise from below. So I think it's the right configuration. So I'm going to stay with that, but I'm going to drop that resistor, the 15K, down to, say, like 5K, like 5K. It's draining kind of slow. It's interesting. That will zap you for quite a while, even though it's on standby. See what happens when we shut the main power. It drops a little faster. So that drops pretty fast. It's completely below dangerous level within a few seconds. I really should stitch this in there. So let's power back up, and we should spin through all 4 tubes just to take a look. So we're for 434. We're coming up. Hopefully it should hit 35. It's getting there. So the tubes are warming up, and we don't care about them being perfect. I just want to kind of spin through 35 on the next tube. 37. Oh yeah, it's a little hotter there. 33. So those 2 tubes, 3 and 4, are on one side. That's unfortunate because they're quite a bit different, but they're hooked together in parallel. 35 and 35. Those 2 tubes are matched really closely. And this tube and this tube are not way different, but not optimal. Okay, so, and I could identify which is the offending tubes. I should write on them what the current value is when we're done. 35. So these 2 are just like matched. So I should keep track of those 2 for 50 watt amps. 37. 34. So it's not terrible. I mean, they probably call this a match set. I went ahead and settled on a 7.5K resistor for that fixed part of the bias circuit. And so right there, like half scale, I have these 70%. And the nice thing is now it can go down to 37, 36, 37, which is 35. Where's matching down there? And that is well below the 60% bias point. That's like probably a 50% or so bias point. So we can get all we need out of this thing too on the other end of the scale. There's where we normally bias it. And then we can easily go up to as high as 70. There's 70. And we can go to 80 even, which is 78. 80 is 110%. So we can back. Here's where we're supposed to be. There, now we have real bias control for this Bassman 100.